We want to proceed and look at another law that we can use to describe the gases in the atmosphere, and that is now the combined law, combined gas law. Now, combined gas law is also called the ideal gas equation. Ideal gas equation. Now, this law, we are combining Boyle's law with Charles' law. Now, when we combine Boyle's law and Gay-Lussac's law, what we call the Charles' law, we know that Boyle's law, when we were stating it, we did say that this law said that at a fixed mass volume of gas, the pressure of the gas is inversely proportional to the volume. And we did find that P, when we equate the two gases, which is Boyle's law, P1 V1 is equal to P2 V2. Now, in describing the Charles' law, we did say that at a fixed mass of a gas, the volume of the gas is directly proportional to the temperature, provided the pressure is kept constant. Remember, in Boyle's law, the temperature is kept constant. That's why we are not evaluating it using temperature. When you look at our equation, it is P1 V1 is equal to P2 V2. Now, for the Charles' law, we say that the volume of a fixed mass of a gas is directly proportional to the temperature. Here, we say that pressure is constant. Now, in our expression for the formula, we need to say that V1 over T1 is equal to V2 over T2. So we want to combine this with this. Now, when we combine these two laws, we are going to get P1 V1 over T1 is equal to P2 V2 over T2. Now, again, you can be told to identify the value of P, the value of V1, the value of T1 by making each the surrogate formula of the other. Let's begin with the first one, identifying P1. So P1 is equal to P2 V2 over T2 times T1. V1 is equal to P2 V2. You're looking for V1 times T1. Okay? I hope you're going to mess up. These things the same. We had said for P1, it is P2 V2 over T2. Sorry, let's just do it again, stepwise. Let's do the first one. We're looking for the value of pressure 1. Pressure 1 is equal to pressure 2, volume 2, all over volume 1 times temperature 1. Let's now look at volume 1. Volume 1 is equal to pressure 2, volume 2, all over volume 1 times temperature 1. Sorry, we're looking for volume 1, temperature 2 over P. This one is supposed to be P1, sorry for that. So it is P2 V2 over P1 times temperature 1. Let's now look for the value of T1. Now to get the value of T1, we say T1 is equal to P1 V1, because we cross multiply. Remember, this one was P1 V1 2 over T1 is equal to P2 V2 over T2. So cross multiply, we get that T1 is equal to P1 V1 times T2 all over P2 V2. Now let us now look at the value of, so we have here P1 V1 T1. Let's now go on this side, P2. You can be told to identify P2. Now P2 is equal to, again we cross multiply, P1 V1 all over T. So when you cross multiply that way, it is supposed to be times T2. So it is P1 V1 times T2, because we cross multiply. Okay, P2. So it is looking for P2, that is P1 V1 times T2 all over the value of T1. Okay, all over the value of T1. There's something left. When we cross multiply, that is P2 is equal to P1 V1 times T2 okay, P1 V1 times T2, then that is P2, we have V2, T1 times V2. Let's go to the other one, that is the value of V2. Now V2 is equal to, look at V2 is equal to, of course, multiply. Again we get P1 V1 times T2 P1 V1 times T2 all over, when you cross multiply, because we multiply by that way, T1 times V times P2. So we have looked at P1 V1 T1 P2 V2, and we haven't done, okay, we have T1 3 P2 V2 T2. Let's now look at the last one, that is T2. How do you identify T2? Again, you cross multiply, making the T2 the surface form formula. When we do so, we're going to get that T2 is equal to P2 V2 P2 P, okay, we're looking for T2, that is P2 V2 T1 all over. So we're looking for T2 all over P1 V1. So that is how we can get each of these values, that is P1, so get the V1, temperature 1, pressure 2, volume 2, temperature 2 for the gases in the combined equation. Thank you.